We're going to learn how to find the equation of a tangent to a circle. This will use some knowledge from my previous videos on perpendicular lines and the equation of a circle. So if you're unsure on either of those topics, I'd recommend you go and check out those videos first. I'll put links to both of them in this video's description. So let's start by taking a circle that's centered at the origin, and we're going to mark a point P on that circle. For this example, its coordinates 2, 8, and we're going to draw a tangent to the circle at that point P, so one that looks something like this. The point of this video is to try and find the equation of that tangent. The first step in this process is to draw a line from O, the origin, up to P. We're then going to find the gradient of the line from O to P. To do this, we draw a gradient triangle, so one that looks like this. We then need to find the change in y and the change in x. The x-coordinate of O is 0 and the x-coordinate of P is 2, so the change in x must be 2. The y-coordinate of O is 0 and the y-coordinate of P is 8, so the change in y must be 8. We can then write down the gradient of the line OP. So the gradient of OP is the change in y, 8, divided by the change in x, 2. And 8 divided by 2 is 4. So we know the gradient of the line from O to P is 4. We're then going to use this to find the gradient of the tangent. This relies on a bit of knowledge from circle theorems. We need to know that when a radius meets a tangent, it forms a 90-degree angle. So this angle in here is a right angle. This means that the line OP and the tangent are perpendicular to each other, which means their gradients must be negative reciprocals. So if we know the gradient of OP is 4, the gradient of the tangent must be negative 1/4. What we do next is write down the general equation of a line, y equals mx plus c. So this is going to be the equation of our tangent, but we know its gradient is negative 1/4. So let's replace m with the gradient of negative 1/4. All we need to do now to complete the equation is work out the value of c, the y-intercept. To do this, we need to use a point that's on the line, and conveniently we know one point on the line, the point P. The point P has x-coordinate 2 and y-coordinate 8. This means we can substitute these values for x and y into our equation of the line, and this will help us find the value of c. So let's replace the x with a 2 and the y with an 8. Since it starts with y equals, we'll have 8 equals negative 1/4 x, so negative 1/4 lots of 2, and then plus c. We now need to just solve this to find the value of c. So we've got 8 equals. To deal with negative 1/4 multiplied by 2, we just multiply the numerator 1 by 2 and we get negative 2/4, and then plus c. Negative 2/4 will simplify to negative 1/2, and then we can add 1/2 to both sides, so we get 8 plus a half equals c, or 8½ equals c. It's often convenient in questions on the equation of a tangent to write this as an improper fraction, so we can convert that 8½ into 17/2. So the value of c, the y-intercept, is 17/2. Now we go back up to the equation here and replace the c value with 17/2. So the equation of the tangent to this circle at the point P is y equals negative 1/4 x plus 17/2. Let's just summarize the steps of what we did. The first thing we did was we drew in the line from O to P, and then we found the gradient of that line OP. We then used this gradient to find the gradient of the tangent. We then wrote out the equation of a line, y equals mx plus c, and we substituted in the value for the gradient. So in our case, it was negative 1/4. We then substituted in the coordinates for the point P, and then solved the resulting equation to find the value of C. Let's try a second example where the point P is in a different place. So this time its coordinates 3, -4. And we'll also look at how an exam question might be worded. So it could say, find the equation of the tangent at P. Give your answer in the form ax plus by equals c. That's slightly different to the previous question, where a, b, and c are integers. So we're still going to start by finding the equation of the tangent using the process we did before. So we're first of all going to draw in a line from O to P and find its gradient. We do this by completing a gradient triangle. So the change in y goes from 0 at the origin down to a y coordinate of -4. So -4, and the x coordinate goes from 0 at the origin across to 3. So 3. And this allows us to write down the gradient of OP, which is the change in y, -4, over the change in x, 3. Which we could write as -4/3. We then use this gradient to work out the gradient of the tangent, remembering that they're perpendicular lines, so we do the negative reciprocal. The negative reciprocal of -4/3 is a positive 3/4. So the gradient of the tangent must be 3/4. Then we write out the general equation of a line, y equals mx plus c, but replace m, the gradient, with our gradient, 3/4. Then we turn our attention to the point P, which has x coordinate 3 and y coordinate -4, and we substitute these into our equation. So we replace the x with 3 and y with -4. So instead of y equals -4 equals, then it's 3/4 of x, which is 3, and then plus c. So we've got -4 equals, we multiply 3 by 3, which is 9, so 9/4, plus c. Then to get c, we're going to take 9/4 away from both sides. So on the left we have -4, subtract 9/4, and on the right just c. We then want to combine these together into one fraction. This time I'm going to rewrite the -4 as -16/4. Since 16 divided by 4 is also 4. Now that I have a common denominator, I can subtract these easily. I do -16 subtract 9, which is -25. So -25/4. Now we've found the value of c, we can come up to this equation and replace the c value with -25/4. So we've now found the equation of the line, it's y equals 3/4 x, subtract 25/4. However, this isn't the answer to the question because it did say to give it in the form ax plus by equals c, where a, b, and c are integers. In order to write it in this form, I'm going to first multiply both sides by 4. This is because my fractions have 4 as their denominator. So if I multiply the left side by 4, that's just y multiplied by 4, which is 4y. And if I multiply the right hand side by 4, well, 3/4 multiplied by 4 is just 3. So the 4's cancel and I have 3x. -25/4 multiplied by 4, once again the 4's will cancel, so it's -25. Now this is almost in the correct form. You'll notice that on the left hand side I need ax plus by, and at the moment my x term is on the right hand side. So I'm going to subtract 3x from both sides. On the left hand side I'll have 4y minus 3x, and on the right hand side if I subtract 3x, the 3x will cancel, so we just have -25. And then the final step would be to reorder the terms on the left hand side. So instead of 4y subtract 3x, it's -3x plus 4y equals -25. This is now in the correct form. You can see it's ax plus by equals c. A would be -3, b would be 4, and c would be -25. Some people may be confused at this point and think that A, B, and C all need to be positive, but they don't. It just said they need to be integers, and negative numbers are also integers, so that's absolutely fine. Now let's have a look at a third example. So this time the question is going to be worded slightly differently once again. It says, here is a circle with equation x squared plus y squared equals 61. So we've been given the equation of the circle this time, that's different. Then it says P, negative 5k, is a point on the circle with k greater than 0, and we need to find the equation of the tangent at P. So the first thing we're going to do in this question is mark on the point P, which is here, and it has coordinates negative 5k. We can start this question in the usual way by drawing a line from O to P, and we're going to try and find its gradient using a gradient triangle. So if we draw in that gradient triangle, the change in y is a bit tricky this time, since the y coordinate of P is k. So the change in y will be negative k, whatever k is. The change in x we can do though, that goes from negative 5 up to 0, so that's a change of 5. But it is possible to find the value of k, and what we need to do is use the equation of the circle that we've been given. So if we write out the equation of the circle, the point P must satisfy that equation since it's on the circle. So we can replace the x with negative 5 and the y with k. So instead of x squared it's negative 5 squared, and instead of y squared it's k squared. Negative 5 squared we can do, negative 5 multiplied by itself gives you positive 25. And now we just need to solve this equation. Subtract 25 from both sides. On the left that will cancel, so it's just k squared. And on the right, 61 take 25 is 36. Then we can square root both sides, and we get k is equal to plus or minus 6. But it does tell us in this question though that k is greater than 0. So we know that k is positive, so in this one, k is actually just 6. So now we know the value of k, we can go back to that gradient. Let's replace the k in the coordinate with 6, and that negative k will now be negative 6. So now we're able to work out the gradient of OP. The gradient of OP will equal the change in y, negative 6, over the change in x, 5, which we could write as negative 6 over 5. Then we can do the gradient of the tangent. Since we know it's perpendicular, we do the negative reciprocal. So instead of negative, it's positive, and instead of 6 over 5, it's 5 over 6. And then we continue as we did before. So we write out the general equation of a line. We replace m with the gradient of the tangent, so 5 over 6. And then we substitute in the coordinates for the point P. So P has an x coordinate of negative 5 and a y coordinate of 6. So it's going to be 6 equals 5 over 6 lots of negative 5 plus c. So 6 equals, we do 5 multiplied by negative 5, which is negative 25, so negative 25 over 6 plus c. We then add negative 25 over 6 to both sides, so we've got 6 plus 25 over 6 equals c. We want to combine these as one fraction, so let's rewrite the 6 as 36 over 6, and then add those together. 36 plus 25 is 61, so we have 61 over 6, which we can write into our equation up here, and the equation of the line is y equals 5 over 6x plus 61 over 6. This time they haven't asked us to write it in a particular form, so this general form will be absolutely fine. Now we're going to have a look at one final question that has multiple parts to it. P is a point 12, 18 on a circle centre 0, 0. L is the tangent to the circle at P. L crosses the y-axis at A and the x-axis at B. And we need to find the coordinates of A and B. The first thing to notice in this question is there's no diagram, and if you do Excel, that's usually the case. If you do AQA, they tend to draw one for you. So if they don't give you a diagram, I'd recommend sketching one out yourself. So we're told it's a circle, center 0, 0, so we know what that looks like, something like this. We know P is on the circle at 12, 18, so we could put that here. And we need to do the tangent at that point, so something like this, and that's called L. We're then told that L crosses the y-axis at A and the x-axis at B. So where it crosses the y-axis, we'll put A, and where it crosses the x-axis, we'll put B. So it's not too difficult to sketch this out for yourself. We need to find the coordinates of A and B. Now it is possible to do this in other ways, for example using trigonometry. But for this video, we're going to use the equation of the tangent. So we're going to find the equation of the tangent first. We'll do that in the way we've done in the previous questions, by starting with the line OP. And we want its gradient. If we draw in a gradient triangle, we can see the change in y is 18, and the change in x is 12. So the gradient of OP is 18 over 12, which will actually simplify if you divide them by 6 to 3 over 2. So the gradient of the tangent will be the negative reciprocal of this, so negative 2 over 3. We then write out the general equation of a line, and replace m with the gradient of the tangent, negative 2/3. Next we substitute in the coordinates of P, the x coordinate is 12, and the y coordinate is 18. So we have 18 equals negative 2/3 of 12 plus c. So 18 equals negative 2/3 of 12 would be negative 2 times 12, which is negative 24. So negative 24 over 3 plus c. Now 24 actually divides by 3 to give you 8. So instead of negative 24 over 3, we could write negative 8. Then we just add 8 to both sides, and we'll find that c is equal to 26. Then we can replace the c in the equation with 26. So we've now found the equation of the tangent. We've been asked to find the coordinates of A and B. Let's start with the point A. The point A is on the y-axis, which means its x-coordinate is 0. So if we substitute in 0 for the x-coordinate, we'll find the y-coordinate. So we have y equals negative 2/3 of 0 plus 26. Negative 2/3 of 0 is 0, so we just find that y is equal to 26. So the coordinates of A must be 0, 26. Now we'll find the coordinates of B. B is on the x-axis, so this time y is equal to 0. So in the equation we'll substitute y for 0. So 0 equals negative 2/3 of x plus 26. We can solve this by adding 2/3 x to both sides. If we add it to the left, we just have 2/3 x, and if we add it to the right, we have 26. Then if we multiply both sides by 3, on the left if we do this, the 3's will cancel, so we have 2x, and on the right, 26 multiplied by 3 is 78. Then divide both sides by 2, on the left this gives you x, and on the right you get 39. So the coordinates of B must be 39, 0. There are some other follow-up questions that you need to be prepared for. For example, part B of this question could say, find the length of AB. If we look at the triangle AOB, we know this is a right angle triangle since there must be a right angle at the origin. So if we focus just on this triangle, AOB, let's mark on its points. We've got point B down here at 39, 0, point A at 0, 26, and also the origin. We know the length from A to O is 26 and the length from O to B is 39. So to find the length from A to B, we can just use Pythagoras, since it's a right angled triangle. So we could say that AB squared is 26 squared plus 39 squared, and if you work that out, you'll end up with 2197. To find AB, we would square root both sides, and if you type this into a calculator, you'll get 46.9 when rounded to three significant figures. So we find the length of AB is 46.9. You'll notice I haven't put any units on, for example centimeters or meters and so on, because we haven't specified units in this question. And that's also quite common for a question like this. The units may literally just say units. And one final question you want to be prepared for is to find the area of the triangle. So it might say, find the area of triangle AOB. Now with the information we've already written on here, this is very easy. We do the area of a triangle equals 1/2 multiplied by the base, so 39, multiplied by the perpendicular height, 26. And if you do this, you'll end up with 507. Just like with the length, we don't have units here, but we know there'd be something squared. So the question may give you the units as units squared.